I'm going to do problem 1988, BC5. Some of the key information that I'm given says as follows. I have a curve, which is determined by y equals 1 minus sine of x. I know that it's supposed to be bounded by the y-axis, which would be right here, and the x-axis. Since the y-axis is when x equals 0, I know that's where I start. To figure out where it ends, I guess I need to know when does y equal 1 minus sine of x equal cross the line y equals 0. So I'll set up an equation, 1 minus sine of x equals 0, 1 equals sine of x, sine inverse of 1 would equal x. There's only one answer that comes back from sine inverse, although there are numerous answers here, but the first answer is also the answer that comes back. That's x equals pi over 2. Therefore, my limits are going to be from 0 to pi over 2. I am reading the paragraph, and in the second line it says, for each x, the cross-section, so you can't see me annotate, I'll write it down. The cross-section is going to end up being an isosceles right triangle. And since an isosceles right triangle has two sides that are equal and a right angle in between them, that's what I am looking to use. However, it says in there is that the hypotenuse lies on the xy plane. What does that mean? Well, let's draw our graph again, or with a curve. And this segment is going from the x-axis to the y-axis. Therefore, this whole sheet of paper right here is the xy plane. So the hypotenuse, which is this piece right here, hypotenuse, is actually going to be the line segment from x comma 0 to x comma 1 minus sine of x. And what's going to happen is, and this is not 3D of course, but this is going to be on the plane, and this is going to stick out, the point will stick out from paper. And this will be x, this will be x, and this will have been 1 minus sine of x, because that's the length of your hypotenuse, because this is the hypotenuse. Therefore, it would be helpful if I came up with a way to figure out, how does x and 1 minus sine of x all relate. But let's be careful here. I'm being asked in question A is to find the area of the triangle, specifically the isosceles right triangle. And since a right triangle can be computed by going on just any right triangle, or any triangle, 1/2 base times height, I need to be able to plug in bases and heights. Since this could be the base, and this could be representing the height, I guess I could say area of this triangle is going to be 1/2 times x, since the base and the height are the same, and I can come up with 1/2 x squared. But I also know that x squared plus x squared equals 1 minus sine of x squared, because that's Pythagorean theorem, which says that 2x squared is equal to 1 minus sine of x quantity squared. Well, I'm looking for something that looks like this, so since this is 2x squared, if I would go out as far as, dividing this by 4 on both sides, I would actually have 1/2 x squared equals 1/4 times this quantity, 1 minus sine of x quantity squared. And I could actually fill that in and say the area formula, A of x, will be computed by going 1/4 times 1 minus sine of x quantity squared. Now that may have been too big of a jump, so let's go back and take this original line and just take it one step at a time. If I would have simply said, instead of dividing both sides by 4, divide both sides by 2, I could have said x squared equals 1/2 times 1 minus sine of x quantity squared, and then I could substitute that into that spot right here, and I would still be able to come up and show that 1/2 times 1/2 is going to equal to 1/4 down here on the bottom. So my final answer for this question A is A of x equals 1/4 times 1 minus sine of x quantity squared. So now if I'm going to find volume, the volume for this problem is computed by taking the integral of the area formula from two limits, in this case 0 to pi over 2, which means I'm going to be taking the integral from 0 to pi over 2 of 1/4, I'll put the fourth in front, times 1 minus sine of x quantity squared dx. If I work this out, this would end up being the same as 1/4 times 0 to pi over, oh, that should have been pi over 2 back here, pi over 2, of, and foiling this out, remember 1 minus sine of x squared is 1 minus sine of x times 1 minus sine of x, it would actually have been 1 minus 2 sine of x plus sine squared x dx. So, a lot of times as the problems get more complicated, I try to make them simpler, as in I look at each piece individually. I look at an integral of 1/4 from 0 to pi over 2 of 1 dx. Then I subtract an integral of 1/4 from 0 to pi over 2 of 2 sine of x. And then I will add the integral of 1/4 times the integral 0 to pi over 2 of sine squared x dx. Let's get that dx in there. Well, the first one, and I'm going to just jump down here a little bit, is pretty straightforward. The antiderivative of 1 is x, and that would mean that this piece is going to be 1/4 times pi over 2 minus 0, and that works out to be pi over 8. The second piece is requiring me to maybe move the 2 in front, and so instead of saying 2/4, I look at it as 1/2 the integral of 0 of pi over 2 sine of x dx. And I remember that my antiderivative of sine is negative cosine, so negative half of negative cosine of x going from 0 to pi over 2 might be better suited by saying positive 1/2 of cosine of x going from 0 to pi over 2. Well, if I go 1/2 times the cosine of pi over 2 minus the cosine of 0, well, cosine of pi over 2 ends up being 0, and the cosine of 0 is 1, and I find out that I have 1/2 times 0 minus 1, and so I come up with negative half. The third piece is the tricky one. And this is actually called, it uses trig substitution, and it's used in our Calc 2 lessons in the future. But it's not a bad time to start introducing it now. You sometimes have to rewrite trig formulas into other ones. And in this case, we're going to pull out a half angle theorem. And this is in the front of the book. It's in your opening cover near the bottom right. And it says that if you have sine squared x, that is also known as 1 minus cosine of 2x all over 2. So I guess instead of writing plus 1/4 times that sine squared, I could actually write this as 1/4 times 0 over pi over 2. I'm going to take a step and actually break it up so I can have this as 1/2 and minus cosine of 2x over 2. So I'll have 1/4 of the integral 0 to pi over 2 of 1/2 dx. And then I will subtract 1/4 the integral from 0 to pi over 2 of, and since that's already negative taken out, I'll just put the half here again and cosine of 2x dx. Well, let's scoot this over here a little bit. The antiderivative of a half is half x. And that goes from 0 to pi over 2, and that'd be added to a fourth. And so, very quickly, I'm going to find out that I have 1/8 times pi over 2, because I could pull out the half if I want right away, minus 0. And since that's minus 0, that just means that I'll have 1/8 times pi over 2, which means I'll be adding on a pi over 16. The cosine of 2x, on the other hand, will require a little bit of u substitution. If I say u equals 2x dx, then I would realize that dx or du would equal 2 dx. And if I just want to do a simple dx substitution, it would be 1/2 du equals dx. So, what I've got going on, there's a lot of information here. First, this half will have been pulled out to the front. So I have minus 1/4 times 1/2 times, and because of the 1/2 du over here, I'll actually pull out another half out, so I can just simply write this as the integral of cosine u du. I didn't even get to the limits. Let's do the limits way over here, which is if I say x or u equals 2x, then technically 0 would go to 0 and pi over 2 would go to pi. So when it's all done, I'm going to do the antiderivative of minus 1/16 from 0 to pi of cosine u du. And its antiderivative happens to be sine of u going from 0 to pi, which means I'll take 1/16 of sine of pi minus sine of 0. The funny thing is, both of those numbers are 0, so all this work was for naught because I essentially add 0. And so I come up with an answer of pi over 8, which is actually the same as 2 pi over 16, plus pi over 16 equals 3 pi over 16 minus 1/2. And that will be the volume of this particular object.